These are solutions to Melham's Math 120 exam number 5. Number 1, square root of 64, x to the 4th, y to the 10th. Square root of 64 is 8. Square root of x to the 4th is x squared. Square root of y to the 10th is y to the 5th. Number 2, 5 radical 12 minus 2 radical 27. Square root of 12 can be written as 4 times 3. 27 is 9 times 3. Square root of 4 comes outside, becomes a 2. Square root of 9 comes outside, becomes a 3. You have 10 radical 3 minus 6 radical 3, 4 radical 3. Number 3, to rationalize the denominator, you multiply by the conjugate of the denominator. That's radical 3 minus 1, top and bottom. So the numerator is 4 times radical 3 minus 1. The bottom is a squared minus b squared, so that's 3 minus 1, which is 2. 4 cancels a 2. 2 times radical 3 minus 1, or if you distribute 2 radical 3 minus 2, both are okay. Number 4, square both sides. So radical 3x plus 1 squared equals x minus 3 squared. This side, the square root and the square cancel out, 3x plus 1. X minus 3 squared is x squared minus 6x plus 9. It's a quadratic equation, so put everything on one side, set it equal to 0. Subtract 3x, subtract 1 on both sides. 0 equals x squared minus 9x plus 8. Factor in the x minus 1, x minus 8. So x equals 1 or x equals 8. But we have to check. If you plug in 1, you do not get an equation that's true. Square root of 3 times 1 plus 1 is not equal to 1 minus 3, plugging back in the original. You get the square root of 4 is negative 2. That's not true. However, 8 does work. Square root of 3 times 8 plus 1, is that equal to 8 times 3? 8 minus 3. And 3 times 8 is 24, plus 1 is 25. Square root of 25 is indeed 5. So the only real solution is x equals 8. So you have to throw out the x equals 1. It does not check. Number 5, 3 minus 4i squared. Square of a binomial, 9 minus 24i plus 16i squared. That's like a squared minus 2ab plus b squared. Anytime you see an I squared, that's a negative 1. So 9 minus 24i minus 16, negative 7 minus 24i. Number 6, f of x equals negative is 2 to the x. Go from negative 3 to 3, negative 3, negative 2, negative 1, 0, 1, 2, 3. Plug in 0, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8. 2 to the negative 1 means 1 over 2 to the 1, or 1 half. 2 to the negative 2 is 1 over 2 squared, 1/4. 2 to the negative 3 is 1 over 2 cubed, 1/8. So plot the points. Exponential functions tend to look something like that. Number 7, y equals log base 2 of x. If you rewrite it without the log, it's 2 to the y equals x. Well, you basically just switch around the x and y here. So I just take these numbers and switch them. So x is 1/8, 1/4, 1/2, 1, 2, 4, 8. Y is negative 3, negative 2, negative 1, 0, 1, 2, 3, which is just the reverse of this, because the equation just got reversed. Instead of y equals 2 to the x, it's x equals 2 to the y. Plot the points, it looks something like that. Number 8, 3 log x, that's an x, minus 1/2 log y. The coefficients can come back up as exponents, so 3 goes up, half goes up, log x cubed minus log y to the half. The minus sign here means make it a quotient, log of x cubed over, and y to the half means square root of y. Number 9, take the natural log of both sides. By doing that, from 3 to the x equals 16, x can come down in front. X natural log of 3 equals natural log of 16. Divide both sides by ln 3. So x is natural log of 16 divided by natural log of 3, which is approximately 2.5237. And finally, number 10, log base 5 of x minus log base 5 of 3 equals 1. There's a minus sign here, so I can write it as a log of a quotient. Log base 5 of x over 3 is 1. Unscramble it, get rid of the log. 5 raised to the first power is x over 3. 5 to the 1 is 5. Multiply both sides by 3. And the final answer is x is equal to 15. All right, so these are solutions to Melham's Math 120, exam number 5.